of the given numbers. So it says express each number as a product of its prime factors, and we are given the 5 parts here. So let us start our answer with the first part, that is 140. So let us do the prime factorization of 140. So it will be, so here prime factors are the numbers. First of all, you need to know that what are prime numbers. So the numbers which are divisible by 1 and themselves. Alright, so those are the prime numbers. So prime numbers are 2, 3, 5, 7, 11. These are the prime numbers. Alright, so this is divisible by 2, right? So 270. After this, again it will be divisible by 2. We'll be getting 35. After this, it is not divisible by 2. Then we'll check, is it divisible by 3? But it is not divisible by 3 also. So after this, we'll check that is it divisible by 5. So yes, it is divisible by 5. And then we are getting 7. And 7 is divisible by itself only. So these are the prime factors. Hence 140 is equals to 2 cross 2 cross 5 cross 7. Right? These are the prime factors for the given number. So 2 raised to power 2, we can write it as like this. Right? So this is how we represent a number in its prime factor product. Now let us solve the second part. We have 156. So 156, first of all it will be divisible by 2. 278. Again 2. 39. Now this is divisible by 3. Right? Not 2. So 13 and 13 is divisible by 13 only. So hence 156 can be written as 2 cross 2 cross 3 cross 13, which is equals to 2 raised to power 2 into 33 into 13. Now the third part, it says 3825. 3825. Now let us check if it is divisible by 2. No, it is not divisible by 2. It is divisible by 3. So let us divide it by 3. 1275. Here we'll get again 4 to 5. Now it is divisible by 5. We'll get 85. Again 5. We will get 17. And 17 is divisible by itself only. So hence 3825 can be represented as 3 cross 3 cross 5 cross 5 cross 17, which can be written as 3 square 5 square into 17. Now the fourth part, 5005. This is divisible by 5. This is divisible by 7. This is divisible by 11. And this is by 30. So we can represent 505 as 5 cross 7 cross 11 cross 13. Let me tell you one thing here, that you must be thinking that how do we know that is it divisible by this or not without checking. So for that we have divisibility tests. So let me write those divisibility tests for you here. I should write them in the starting, but it's fine. Let us write here divisibility tests. So first of all, to find out the prime factors of a number, we'll check the prime numbers only. Alright, divisibility with prime numbers only. So it will be 2, 3, 5, 7, then it's 11, 13, 17, and so on. Alright, so these are the prime numbers. So we will only check the divisibility with these numbers. Right, so divisibility for 2, if the number has 0, 2, 4, 6, 8, that is the even number at the end, so it will be divisible by 2. If the numbers digits, sum of digits of the number given is divisible by 3, then the number is divisible by 3. That is, if we have a number, let's say 144, so the sum of digits will be 1 plus 4 plus 4, that is 9. So if this 9 is divisible by 3, then this number will also be divisible by 3. Alright, for 5 the divisibility test is, if the last digit, that is, if you can say the unit place digit is 0 or 5, then it will be divisible by 5. For the divisibility test of 7, you can say that remove the last digit from the number and double it, and then subtract it from the remaining number. Let us say if we have 1001, right? So now just take the last digit. This is 1, so 100. Now double the last digit. Double of 1 will be 2. So 100 minus 2, that is 98. So if this is divisible by 7, then this whole number is divisible by 7. Alright. Similarly, we have the divisibility tests for 11, 13 and 17. You can easily check it from the books. They are given, and basically these are the normal divisibility tests which we need. We don't require much for 11, 13 and 17. So let us do the fifth part here. Fifth part says that 7429. So now if you apply here the divisibility tests, so here you can simply see that this is not an even number, therefore it will not be divisible by 2. Now for 3 you have to sum all the digits. That means it will be 11. 11 plus 4 is 15, and 15 and 7 is 22. So it is not divisible by 3 also, because 22 is not divisible by 3, right? So next is 5. Next prime number is 5. So the end digit is not 0 or 5, so it will not be divisible by 5 also. Now next is 7. 7. Remove the last digit, double it. It will be 18. And subtract it from the remaining number. That is 74 minus 18. So what will, it is not divisible by 3 also, because 22 is not divisible by 3, right? So next is 5. Next prime number is 5. So the end digit is not 0 or 5, so it will not be divisible by 5 also. Now next is 7. 7. Remove the last digit, double it. It will be 18. And subtract it from the remaining number. That is 74 minus 18. So what will be 74 minus 18? So 742 minus 18 will be 624. So which is not divisible by 7. If you want to check it, you can check it again. But I know that it is not divisible by 7 also. Similarly, you will check all the divisibility tests, and you will find out that this number will get divisible by 17. Alright. So 17 will give us 437 as the quotient, and then this 437 will be divisible by 19, which will give us 23, and 23 is also a prime number, so it will get divisible by itself only. So we'll get 1 here. So this number can be represented as 17 cross 19 cross 23. That's how we have solved the